In this video, we demonstrate how to optimize your collections by only loading the information that is currently needed by the application by implementing the IEnumerable and IEnumerator interfaces. So what I've done is create a simple Visual Basic Console application called IEnumerable IEnumerator VB. And what we're going to do in this is show how to create a collection that's smart about how it loads objects into it. Instead of loading in like 10,000 items into the collection right away as we create an instance of our event log reader, we're only going to load those items in as we need them for our application. So to illustrate this, what I've done is create a wrapper around the event log class, only because it has access to lots of data. You could do the same thing when obtaining records from a database, when loading files from the hard drive, when populating any other collection that has information where you might want to conserve system resources. Be cautious about how the data is loaded into that collection. So this wrapper consists of a class called event log reader, and as you'll see, what we do is create a new instance of the event log from the system.diagnostics.eventLog class as EL. And so our event log reader will just manage the event log object. Notice that our event log reader implements IEnumerable. Now, if you recall from our previous video, what this will do is force us to implement our getEnumerator method. That's the only thing IEnumerable does. It forces us to implement getEnumerator. And from the previous video, getEnumerator returned an instance of an enumerator object. The enumerator object is smart about how to iterate through a collection of things. So our event log reader also contains a class called event log reader enumerator. When somebody calls the getEnumerator, it will return an instance of our event log reader enumerator class. This class implements the IEnumerator interface. That means that this class has to implement the following methods or properties. Current, and that'll return back the current item in the collection. It has to implement the moveNext method, which means whichever your current method is, move it forward, move it to the next item in that collection. And then it also has to implement the reset method, which means no matter what item you're on, go back to start. Go back to the first item in that collection. So let's do this to start off with. What I've done is create a very simple little consumer of our event log reader application. I'm just going to go ahead and put a breakpoint here at the very top, and let's step through this application to see exactly what it does. I'm going to hit F5 on my keyboard, which kicks off the process, and let's move some windows around here and move this down and go back. Okay, here we are. So we are in our submain, and we're at our very first line of code where we're creating a new instance of the event log reader class. So it calls the new from the event log reader class. It creates an instance of the event log class. And then we're going to start looping through each item in our event log reader. Now up to this point we haven't loaded any items into our event log reader, so it's going to be empty. But what we'll see is when we hit the F11 key on our keyboard, is the first thing it calls is getEnumerator. This happens behind the scenes without us even requesting it. And it's going to return back an instance of the event log reader enumerator object. That kicks off the new method of the event log reader. Which basically sets a private reference to the parent that was passed in, xparent as event log reader, so it knows how to refer back to its parent. And so now we're back to our for each in our example. And the very first thing that it does is it has to call move next, because at the very beginning of a collection it will move to the item that, or to the right before the first entry. So the first thing it has to do is call move next to get to the first entry within the collection. Now what we do is we check to see what our current index is, which, as you can see here, that popped up, current index equals 0, versus how many entries are currently in the event log. In this case, there's over 1,000 entries. So if that's the case, then, which it is, then what we're going to do, we'll step into the next one, is set the current entry equal to the current index. Our current index is 0, so we're going to grab the very first item and set that as our current entry. And then we're going to increase the current index and return true. So we've moved to the next item and we've set it equal to our current entry, private reference to our current entry object, that is an event log entry. So that'll get returned in just a moment. Notice that the next thing that happens is that it's going to get a reference to the current item. And so now we're able to use the current entry within our calling application, get its message, and print that out to the console window. So now we take a look at our console window and we see that it loads it. Great. So now we hit next and it goes through the whole process again. Current index is 1. Our count is 1,005, so we're only on the second item of our collection. Now let's go ahead and load just one more. So what we could have done here is just at the very beginning of this loaded every single entry, all 1,000 entries from the event log into our collection. But the calling application may have not needed all 1,000. They may only want 10, and we'll show an example of that in just a moment. And so we would have done all this work and loaded all this data into our custom collection, but then only needed 10 items. Well, that doesn't make a whole lot of sense. We wanted to be smart about how we did this. So that's why it's only grabbing one at a time as it needs it. It gets the current item and prints that one out to the console window. So now we see this second entry here. And we can go on. Now, we don't want to do that because it'll loop through this essentially 1,000 times. So we're just going to go ahead and hit the stop debugging bug on our interface here. So as the note says here, notice how little that has to be done by this code in order to loop through. And notice how much was going on behind the scenes in the event log entry class. There was a lot going on. It was managing the whole process of loading just one item at a time. So let's go ahead and dig a little bit deeper. I'm going to paste another section of code just called example 2. And let's comment this out for the time being. And here what we're going to do is just explicitly or get a reference to the enumerator interface and explicitly call the current move next and reset methods on it. So here we're going to get a new instance of the event log reader enumerator called myenum, and then call and then set it equal to the get enumerator, whatever's returned by it. Now that we have that, we can start calling these methods ourselves on our client application. Let's go ahead and set a breakpoint here this time. Let's go ahead and get rid of that. And notice what happens this time. So we're going to create a new object called myenum. It's going to create a new. And now we're going to get enumerator. It returns back an instance of the event log reader enumerator. And now we can call the reset. The current index, it's going to set that. And then it's going to call if move next equals true. So move next must return a Boolean whether it was successful or not. And here, since we haven't grabbed anything back yet, we grab the first item. And now we're able to get the current item, which is going to be a dictionary object, and use that current entry to grab its message. So notice that it prints to the screen the first item. So this is a very simple example, but it shows how we were able to take control on the client side and call these methods by implementing the get enumerator. This is very analogous to what we did in the previous video on doing this on just an iDictionary object. So it's great in so much that we're able to control the process. Now the next thing I'm going to do is just paste another example right underneath this one. Let's get rid of this breakpoint and set the breakpoint here. In this case, I'm going to show you why this technique is important. Again, there's over 1,000 items in the event log. Now, as it turns out, the event log is pretty harmless. To load in 1,000 items, not a big deal. People have a lot of memory. But what if you were having to load from a database and that database was remotely and you wanted to hold on to those objects? What if you only needed 10 of those items instead of making, and each call was very costly? Or what if you had to load in 10,000 files worth of data? What are you going to do then? Are you going to attempt to load them all up? You know, there's a lot of homegrown techniques to accomplish what we're doing here, but this is the .NET way to do it, and it allows us to plug in nicely into its architecture. So this is where we begin to see the power. We only want to load up 10 items because that's all that our client is going to be able to use. We're only going to go from 0 to 9. So if we load from 11 through 1005, we're going to be wasting a lot of CPU. So what we've done here is just custom call the move next, just like we did in the previous one where we were able to get an event log entry item by grabbing the current method from the enumerator, and then we're able to print things out. The event ID, the time generated, and that kind of stuff. So I'm going to go ahead and set a breakpoint down here as well and just run through it. And notice at the end, as we bring up our console application, that we see it's only run through this 10 times from 0 to 9. And I guess we have the error ID and the time that it occurred and so on. And we'll go ahead and let it finish out. So this technique is very useful, again, whenever you need to control how your collections are going to get their information. And if you choose to do it only on an ad hoc basis, this is the route that you want to go. So I hope that this video was beneficial, that you enjoyed it, and that you learned a little bit more about what goes on behind the scenes as classes begin to